Hello. So this is a quick video about file descriptors because I think it's the easiest thing to grab, easiest marks, but could be a little bit confusing at first. So this video try to give you my thought about it and how to proceed. So I think one trick that Miyasko told us about is that when you try to start when you start a file descriptor problem, you always look at the inode table, start from the inode and how things are looking at the desk. So let's say this is the inode table, right? This video will be just talking about duplication. So let's say you have an inode for a file called a.text. The only way you can get so there are two types of duplications. One I would say like as a pointer, and one as an entry. Okay. You will see what I mean soon. So to duplicate this entry, the only way is like basically to copy the file, right? But that will be completely different file, right? Because it will have its own inode, it will have its own data. That's recopied. If you do a symlink, that's just a pointer to it, right? Or like hard link, whatever. Actually, soft link will be pointing at the same inode, where inode will be basically, yeah. Well, oh, sorry. Soft link will be talking to the inode itself. That's the soft link. Will be directly connected to the inode as we've seen in this class. However, the hard link will be basically pointing to its parent inode. So this is a side point, but I think yes. So we were talking about duplicating this entry, right? That's through a copy. That's through copying the file, all right? And to get a double pointer, there are a couple of ways. One of them is through soft link, and we'll see the other one. Okay, we'll see what's the other one. Now we move back to say the OS level now, from the desk to the OS. So the OS kernel will have something called the open file table. Okay, and we have anything that any file that you open. Now let's just do this: the pointers to it and entries. Okay, so the only way to get another entry here, let's say you want to get an entry for A, it has to be through open. Okay, what I mean by that, like the open function. So if your process called like open A, you get an entry here called A. Okay, and you get, let's say, file descriptor X, let's say, right? So this, let's say, I'm just going to do X here just to know. Let's say, and then you do another open again of A, you're going to get another entry, right? You're going to get like A, but it was called, let's say, through Y. Okay, so only the open function can do that. Okay, now if you open twice, this is we call basically, let's say 2x open. If you call, it will give you two pointer to the same file, right? Let's say we said this is duplication, so it's probably will have a different name or different path, so it's a unique entry. Let's say one is in temp A, and the other one, let's say, you can't have it in the same file, of course. So let's say etc, right? A. So definitely, when you open here, you will have like different one, right? Whether you, like you have to have the path temp or etc with it. So it's a completely different reference here, right? So let's say we didn't do the duplication here, but we opened twice the same file. So each of them will have a duplicate entry in the file. So this is the only way you can get duplicate. And however, as a result, this will not duplicate the will not we'll just have a duplicate pointer, as we said here. If you open twice, you're gonna get two pointers on this. Okay, so to duplicate the entries here, you copy the file, and to get double pointer on one, you basically, whether you have a soft link or you have to call open twice, because open twice will just create another entry that points to basically the same place if you open the same file. These are the only two ways to this is basically the only way that you can get a new entry here, right? Only through open. Now, let's go back another level to talk about how you can get duplicate pointers on this table. And that it's necessary to go back to the user, the process level. So what's called here is file descriptor, right? Whatever. So file descriptor will have like some entries, you know, the default one, the user convention like 0, 1, and 2 for input, output, and error. However, the entries, let's have our own table here. So if you want to duplicate entries, or you want to, I don't think you duplicate pointer. We'll see how that goes. But um, so one way you can duplicate entry, let's say we called our the old one open A. This we said it will create one here, right? But also it will create one entry here, right? And that would be like A for X, and it would put point here. Now, if you call open again and you call it Y, it will create another file descriptor because open will necessary excuse me, open this, right? Because when you call open again, it definitely creates a new entry in the open file, and therefore you need a unique identifier for it in the file descriptor, right? So this is one way through open. You can actually open another entry here. So let's say through open. The other way that you can get another duplicate entry in here, which is through calling duplicate. So let's go back. Sorry, I should have not deleted that. So it's open of A. Okay. The only way you can get another entry here is through duplication. So what I mean by that, so if you call duplicate and you call it Z, and you say, I want you to duplicate X, that will take the whole thing with its pointer and duplicate it for you here. So let's say this is A, let's say called through and returns Z for you. That will just points here. If you pass in Y to the duplication and you still have the handle, it will point, it will just point to this one. But we chose X, so it will definitely point to where X was. So this is how you can get another duplication in this file descriptor, which will say through the function duplication. And the first one was open because open necessarily opens one here, and therefore it gives you a unique one here. The last way you can get another pointer, here is basically through forking, right? So what happened when you fork the child process? This is the child. Let's just do it in another color so don't mess around. Oh, let's do that. Okay. So if we create another child, it will just basically inherit A to X. All right. So basically you get another pointer here. So let's just call, when you call fork, we'll probably miss another one. And through duplicate, right? So basically duplicate will give you another pointer to this table. Basically, I mean another pointer, not just any regular pointer. I mean like to one entry. And also fork now, right? Because what fork will do, excuse me, what fork will do, we'll just create a child, and the child will inherit the file descriptor, and that means all the pointers that used to be in the previous one will be just copied and would be just basically copied, and therefore they have the same pointer of the open file table entry, right? The same pointer to the entry in the open file table. Therefore, you're gonna get another one here. For this one, I don't know, but maybe some of you can leave a comment or something about it. Anyways, so the key idea here is that look how things are looking on the inode table or the desk, and then move this way, see the table, see how many opens you have, right? To decide how many entries you have. Even if it's a child, do another open separate from the parent, you will have another entry here, but it will be basically just unique to the child. If the child do it after the after like the if whatever PID equals 0, whatever we do, and then we do the child stuff here. If the child opens one here, you will have another entry here, and it will be only special to it, right? But if it was before the forking, then the child will just inherit it automatically, right? So this is duplicating the entry. Uh, Also, pointing to an entries it will come from the process. If the process got duplicated, the file descriptor entry, or forked its process, basically, and it's already pointing to the open table, then you get another handler, another file descriptor with the same pointing to the same place in the open file table. Finally, in the process level, if you call open, you're gonna create another entry here, and therefore you're gonna get um, basically you're gonna get a new entry on this table. If a child process only do it, you're gonna get it on the child process. If before forking, you get it in both of them because the child will inherit. And then calling duplication, basically will just the parent will create the parent or child will create an entry here, but it uses the old pointer of whatever you basically duplicated. Hope this helps, and yeah, good luck at the finals. Study hard.